Not long ago, less than 2 decades in the past, something began to stir beneath a vast stretch of land in Asia. Cracks split open across multiple nations, tearing through roads, farmland, and in one astonishing case, cutting a man's house perfectly in two. This was no ordinary earthquake. Scientists soon realized it was the opening chapter of a continental rift, a process that, once it begins, can reshape the world itself. When a rift forms, it means an enormous landmass is slowly breaking apart. In time, new continents rise, fresh oceans surge into the gaps, and islands appear where there was once solid ground. Our planet will never look the same again. But what could cause such a massive rupture in the Earth's crust? And what would it mean for the millions who live there and for the rest of the world? The first clear evidence came in 2005, when dramatic images and field reports revealed a widening tear in an Asian region along the equator. In geology, a continental rift describes the process of a continent splitting into 2 or more parts. It's not unusual in Earth's history. In fact, every continent we see today was shaped by rifts and the slow but relentless movement of tectonic plates. To truly understand what's happening now, we need to travel back hundreds of millions of years, to when the Earth's land was one vast, unbroken expanse surrounded by a single, massive ocean. That ancient supercontinent, known as Pangaea, was encircled by the great Panthalassa Sea. Over countless ages, Earth's outer crust heated, cooled, and fractured, breaking apart into the continents, islands, and oceans we know today. But the story doesn't end there, because the Earth never stands still. The lithosphere, the rigid outer shell beneath our feet, is broken into about 15 to 20 gigantic tectonic plates. Like pieces of a cracked eggshell drifting atop molten rock, they slowly push together, grind past one another, or drift apart, driven by the immense heat of the planet's core. This motion, plate tectonics, has been rewriting the face of our world for hundreds of millions of years. And if you've ever studied a map closely, you might have noticed something uncanny. The eastern edge of one continent and the western edge of another fit together like 2 halves of a puzzle. That's no coincidence. They were once united until forces deep within the planet tore them apart. And now, in parts of Asia, those same forces may be preparing to do it again. According to detailed observations from NASA's Earth Observatory, a dramatic shift is underway deep beneath parts of Asia. Along the far eastern edge of the landmass, one tectonic plate is slowly drifting away from a much larger, older plate to the west. While geologists have different local names for these plates, the movement between them is clear, and it is changing the continent's future. What makes this even more remarkable is that both of these plates are also moving away from a third plate to the north, creating a geological crossroads. All 3 meet in a region marked by a massive Y-shaped rift system, where deep valleys and fractures cut across the landscape. This network of rift valleys stretches for thousands of miles, and if the eastern plate ever fully detaches from the larger western plate, the result will be nothing less than the splitting of Asia into 2 enormous land masses. For scientists, it would be the most significant continental breakup since the age when the Americas and the Old World were torn apart hundreds of millions of years ago. But this is not a change we will see completed in our lifetimes. Experts estimate that a total separation would take 5 to 10 million years. Still, a complete break is not the only possibility. In one scenario, a large portion of the eastern plate could pull away, forming a new inland sea between the 2 land masses. This new territory could include several existing nations and parts of others, reshaping coastlines and national borders. In another possibility, only a smaller eastern section would separate. For some countries, this could be an unexpected advantage. Nations that are currently landlocked could suddenly find themselves with direct access to the sea, unlocking new opportunities for trade, fishing, and economic growth. Some experts predict that in the far future, nearby seas could flood into the Rift Valley, creating an entirely new ocean and leaving a section of Eastern Asia as a separate, smaller continent. For now, the process is slow, incredibly slow, with the plates moving apart at roughly 1/4 of an inch each year, about the same rate your fingernails grow. Yet even at this pace, the forces at work are relentless, and the future map of Asia may look very different from the one we know today. At the moment, the movement between these massive plates is incredibly slow, roughly the same pace your toenails grow. But the question remains, how does a rift like this actually begin? Geologists and geophysicists still debate the details, yet one leading theory has gained the most support. It suggests that heat from deep inside the Earth increases in certain regions, creating what are known as thermal bulges. In parts of Central Asia, these bulges can be seen on topographic maps as elevated highlands. As they swell, the brittle crust above them stretches and fractures into a network of faults. Most scientists agree that such bulges are the result of mantle plumes, vast upwellings of magma that are significantly hotter than the surrounding material. This extra heat weakens and thins the crust, causing it to expand and crack. The process can also spark intense volcanic activity at the surface. Often, before a rift widens significantly, massive volcanic eruptions occur, flooding huge areas with molten rock. Some of these events are called flood basalts, where lava doesn't erupt from a single cone but instead pours out along long fractures, spreading across the land like water escaping a broken dam. One of the most defining features of an active rift is the Rift Valley, a long, low-lying region formed when two tectonic plates move apart. Rift valleys can appear both on land and beneath the ocean. In the sea, they are shaped by a process called seafloor spreading. Unlike river or glacial valleys, which are carved by erosion, rift valleys are created by the raw force of tectonic motion. Many are part of what geologists call triple junctions, points where three plates meet at roughly 120-degree angles. In such cases, two arms of the junction may continue spreading until they form an entirely new ocean, while the third arm, known as a failed rift or oligogon, remains as a valley. A famous example is the Atlantic Ocean, which began to form on the ancient supercontinent of Pangaea. There, two arms of a triple junction tore open the seafloor, creating the ocean basin, while the third arm became a long-standing rift valley still visible today. Rift valleys aren't limited to the land. Many lie hidden beneath the ocean, cutting across enormous underwater mountain ranges known as mid-ocean ridges. These form where tectonic plates slowly drift apart beneath the sea. At these ridges, magma from deep within the mantle rises, meeting the icy seawater and solidifying into fresh oceanic crust along the valley floor. In the northern section of the Mid-Atlantic Ridge, for example, the North American and Eurasian plates are moving apart at roughly 1 inch per year. Over tens of millions of years, this steady pace has carved rift valleys up to 9 miles wide. In the Pacific Ocean, the East Pacific Rise marks another such zone, where the Pacific Plate pulls away from the North American, Cocos, Nazca, and Antarctic plates. Like many underwater rift systems, it is dotted with hydrothermal vents, fissures where superheated water and mineral-rich fluids surge from deep below, a result of the intense geological activity beneath the seafloor. On land, one of the most striking rift systems comparable to Asia's developing fracture is the Great Rift Valley, stretching thousands of miles from the Middle East down into the southern hemisphere. This immense scar on the Earth's surface is geologically alive, its landscape shaped by volcanoes, hot springs, geysers, and frequent earthquakes. In regions where the rift branches into two main arms, each has its own distinct character. The western branch is marked by deep basins and massive lakes, surrounded by lush forests, open savannas, and even snow-capped mountains. The eastern branch is far more volcanically active, home to towering peaks, some dormant, others still capable of eruption. At the northern tip of this system lies a place of extraordinary geological importance, a triple junction where three tectonic plates meet. Here, the edges of an Asian plate, a Middle Eastern plate, and a Northern Oceanic plate are all pulling away from one another, creating a dynamic point from which new landforms, and possibly a future ocean, may one day emerge. The triple junction in Asia continues to widen through the slow but persistent process of seafloor spreading. One arm stretches toward a northern inland sea, while another extends toward a vast gulf. If these rifts keep opening, the narrow valley within the eastern branch could sink so far below sea level that surrounding waters flood in, creating a new strait. Should that happen, the region beyond would be transformed into a continental island, much like how Madagascar or New Zealand stand apart from their parent landmasses today. What makes this rift system fascinating is how its two main branches, though born from the same process, have evolved very differently. The eastern branch is a hotbed of volcanic activity, with eruptions, lava flows, and steaming fissures marking its length. The western branch, in contrast, is carved deep into the crust, holding vast lakes and heavy layers of sediment. One of these is a freshwater giant, the second deepest lake on Earth, while another lies further south, known for both its volcanic surroundings and the steady opening of new cracks along its basin. For geologists, this region is more than just a spectacle. It is a living laboratory, one of the few places on the planet where they can study the birth of ocean basins on dry land. Most rift zones have long since been buried under sediments or hidden beneath the sea, but here, the process is exposed for all to see. Rift valleys often cradle lakes, formed when fresh water collects in the depressions created by the stretching crust. One striking example comes from over 1 billion years ago, when a massive rift began to split an ancient continent in what is now the heart of another landmass. At its center, a triple junction formed, and water eventually filled the deep valley, creating a great lake. In that case, the rift failed to fully separate, leaving the continent intact. Today, that ancient rift lake survives as one of the oldest and deepest on Earth. Another, far to the north, lies above a massive rift valley and holds the title of the deepest and oldest freshwater lake in the world. Its waters plunge more than 5,000 feet, and beneath its surface, sediments have been slowly collecting for over 25 million years. In truth, the actual floor of the Rift Valley lies more than 3 miles beneath the water and mud. This immense northern lake, plunging miles deep, also holds the world record for the largest volume of fresh water, an astonishing 5,700 cubic miles. Far to the southwest lies another remarkable basin, a hypersaline lake at the lowest land elevation on Earth. Its surface sits over 1,400 feet below sea level, and its waters extend nearly 1,000 feet deeper still. Yet, unlike the Great Northern Lake, this one is not a true rift lake. The fracture beneath it never fully developed into a functioning rift. Instead, it is part of a far more complex fault system where tectonic plates grind past, pull apart, and collide in unpredictable ways. Across the globe, some of the most famous rift lakes are clustered in long valleys formed by the stretching crust. These bodies of water range from vast, fresh expanses to shallow soda lakes rich in minerals and life. Among them is an elongated freshwater giant that spans 4 different nations, its depths home to hundreds of unique species found nowhere else. In contrast, another far smaller basin glows red in the sunlight, its color born not from the surrounding rock, but from salt-loving bacteria thriving in its alkali-rich waters. Still another ranks as the 3rd deepest freshwater lake on the planet, its basin densely settled and its waters teeming with an extraordinary diversity of fish. In total, some of these rift lakes hold more species than any other freshwater body on Earth. As Asia's Great Rift continues its slow, patient work of dividing the continent, interest in the region has surged among scientists, conservationists, and governments alike. Beyond its geological significance, The rift holds clues to the story of our own species. Ancient remains and fossils found along its length suggest it played a key role in the journey of early humans. Today, it has earned a fitting nickname, the cradle of humanity, and as the rift evolves over the coming millions of years, it may continue to reveal secrets about both the planet's past and its distant future. Over the decades, this vast rift has revealed astonishing traces of the past, fossils and skeletal remains that have rewritten what we thought we knew about our origins. Among them are the remains of a small, ancient hominin unearthed in a remote valley, dating back over 3 million years, and another nearly 2-million-year-old skeleton found farther east. Many researchers believe that the shifting landscape of the Asian Rift created a patchwork of environments, some lush and wet, others dry and harsh, forcing early life to adapt or vanish. In such a setting, our distant ancestors may have been driven to walk upright, sharpen their wits, and develop tools to survive the swings between abundance and scarcity. But this rift's importance is not locked in the past. Beneath its fractured ground lies a vast reservoir of untapped energy. International projects are already exploring the possibility of drawing geothermal power from its depths, converting underground heat into electricity that could light up millions of homes. A single well here could power an entire city district, a clean, renewable lifeline for regions still in darkness. Yet, the same forces that make this possible also carry danger. Volcanic tremors, shifting ground, and sudden floods can strike without warning. And in certain basins, where valuable resources like oil have been discovered, the promise of wealth collides with the reality of instability, poverty, and environmental risk. For scientists, this is one of the most thrilling natural laboratories on Earth. For those who live here, it is a place of both opportunity and uncertainty. And while the complete division of Asia may take millions of years, the rift is already shaping the fate of its people, its nations, and perhaps the story of humanity itself. As the ground continues its slow, silent pull apart, one question remains. When the day finally comes that the continent breaks in two, who will be here to witness it, and what kind of world will they inherit?